Hi everyone, in this video I'm going to be going over the in-class activity where we were predicting phenotypes when we are given the genotypes. So the first thing we're going to start with is here what I have written. I believe in class we talked about purple and white, but for this example that's what I'm going to go with. So I'm saying that purple is dominant to white wings. So in this example, a homozygous dominant individual, or this top one right here, would be purple. A homozygous recessive would be little a, or white, and then a heterozygous individual, big A, little a, would be purple. So that's important just to kind of know when we're starting out. So the first thing that we're doing is a cross is made between a homozygous dominant individual times a homozygous recessive. So big A times little a, little a. So first thing they want you to do is figure out what the F1 genotype is. And what the F1 phenotype is. So remember, F1 is just the product of what you get after you cross the originals. So here's the parentals. Again, your homozygous dominant and your homozygous recessive, and F1 is that product. So we're going to do big A, and then little a over here. And then we're going to cross the two. And remember, so when we're crossing, we just have two big A's, so we need to make sure that every column has an A. And then the little a needs to be the second letter. Okay, so as you can see, all of these individuals are heterozygous. Meaning they have one big A and one little a allele. So now that we know that they are all heterozygous, we can say 4 out of 4, 100%, whatever you want to use for that are big A, little a. It's also asking for the genotype. So remember that we said that purple is dominant to white. So in this scenario we have here's our heterozygous individuals. So they would all be white. Oh, excuse me, they'd all be purple, my bad. They'd all be purple. Okay, so that's the first question. The second one, if an F1 individual is crossed to a recessive parent, what phenotypes and genotypes would you see? So we're going to take this F1 individual here, the heterozygous individual, and we're crossing it to a recessive parent. So that would be little a, little a. So big A, little a times little a, little a. And as you can see, we have a different split. So instead of everything being the same, we have half of the individuals being heterozygous and half of the individuals being homozygous recessive. So in this case, the phenotypes would look a little bit different. So I would write this one that 1/2 or 50% are heterozygous, the other half are homozygous recessive, and then I would also write their phenotypes. So these would be purple, and then the homozygous recessive, you would get white. Okay, then C, if F1 is crossed with a dominant parent, what phenotypes and genotypes would you see? So again, F1, and then a dominant parent would be big A, big A. And again, you have a 50-50 split. So this top would be homozygous dominant. And then on the bottom, you have heterozygous. So I would say 1/2 is big A, and then the other half is big A, little a. And then, of course, do their phenotypes, but both of these, so your homozygous dominant and your heterozygous individuals, appear the same, so they are both going to come out as purple. because they're showing that they have that dominant allele. Okay, and then the last one, if F1 is selfed, what phenotypes would you see? What genotypes are these? Remembering that self is, you're just like crossing it times itself. So F1, you would basically just be doing a heterozygous individual times another heterozygous. And this is where you get your unique 1 to 2 to 1 genotype, but a 3 to 1 phenotype when you cross two heterozygous individuals. So what I mean by 1 to 2 to 1 genotype, you have one homozygous dominant, one homozygous recessive, but you have two heterozygous individuals. So that's your 1 to 2 to 1 genotype. As for phenotype, your homozygous dominant and your heterozygous, your two heterozygous individuals, all three of them will appear the same. Like, they'll look the same, they'll have the same phenotype. So they would all share purple in this instance, where the homozygous recessive little a would show white. So again, you can write it like this, write it as a ratio, write it as a fraction or a percentage. I think ratios are a little bit easier in this case. So again, the 1 to 2 to 1 is that big A to little a, big A, little a, to then your little a. And just remember that there's two of the heterozygous individuals. So there's two of these. That's how you get the two in the middle. Okay. All right, so that's how you answer question number 1. And then here's kind of a cleaner key in case you want to look at it. But yeah. All right, let's move on to the second question. The second question is asking how to predict the genotypes when you are already given the phenotypes. So in this case, we have winged and wingless fruit. So the first thing you want to do when you're looking at these is just look at all of the different offspring phenotypes. So look at the parental and then look at what you're given. So this is basically the product. So in the last example, we were trying to figure out what the product was, like what the ratio for the offspring would be. This time we're given the ratio of the offspring phenotypes and we're trying to figure out what would the parents be. So kind of looking at this, looks like we have in the first example winged self. We only have winged individuals. However, in the second example, we have a winged self, but we have a 3 to 1 ratio. So that 90 to 30 would be that 3 to 1. So it's interesting that in the first one we have winged self and we get only all winged individuals, but in the second time in the second parental phenotype, we also have another winged self, but it produces a different product of offspring. So this 3 to 1 ratio is what ends up telling us that the winged individuals are dominant. Because right here, winged individuals. Kind of like how we explained in this example here, how the purple, you had your homozygous dominant here, and then your heterozygous individuals, they both appeared as purple. In this example, you have your 3 is showing both your homozygous and your homozygous dominant and your heterozygous individuals. So that's how you know that winged is dominant. Okay, so let's go back up to the top for the winged self. You have all winged individuals and no wingless. So in this case, I know that the individual would have to be a homozygous dominant times another homozygous dominant. And I know this because it's selfed, so it's the exact same genotype being crossed by itself, like being crossed together, so it has to be the same letter. So big A times big A, and that is what would give you a completely winged version. You know that it's not a big A little a, like a heterozygous individual, because that has the possibility of giving you heterozygous or homozygous recessive individuals or wingless individuals. So I'll show you real quick. If you do homozygous recessive, if you do two heterozygous individuals, you can see that 1 to 3 to 1, 1 to 2 to 1 ratio, so that 1 to 2 heterozygous to 1 homozygous recessive. So this homozygous recessive is not being shown here. So that's why we can rule out that it's a heterozygous individual for that particular case. Okay, going back, so then using that same logic, we know that this individual would have to be the heterozygous times heterozygous, because again, it's selfed, so it's the same genotype being crossed by itself. However, we do see wingless individuals, so that little a that I just drew, this right here, this is what is giving you that 30. But the rest of the 90 is coming from your homozygous dominant and then your two heterozygous individuals. Okay, next one, wingless. Actually, really quick, I'm going to make a note that we have our winged individuals can be homozygous dominant or heterozygous, and our wingless can be homozygous recessive or little a. That might help in referencing things. So wingless individual, we know that it has to be a, and it's being selfed. So we know that would be little a, cross with another little a. Okay, moving down to the fourth one, we have a winged individual times a wingless individual. So we know a wingless individual would be little a. And then for a winged individual, we know that it would have to be a homozygous dominant because you're not getting any of those wingless individuals. If you're crossing a, real quick, heterozygous individual, you would have the possibility of getting half of them having that wingless phenotype, in which it's not the case. We don't have any wingless. So that's how we can rule out that it is in fact a homozygous dominant instead of heterozygous individual. Okay, and then number 5, we have, it almost looks like about a even split, so like a 50-50 split. So again, we have a wingless individual, so little a. And then this is when we would have that big A, little a, kind of like I just drew. So you would get half of them being having that wingless phenotype. Okay, and then number 6, it is the exact same as number 4, with having all winged individuals, no wingless. The number does not matter. It does not matter if you have 1,000,000 winged and 0 wingless. The proportion doesn't really matter, just as long as it is a 1 to 0. So again, 161, 46, you could have had 200 to 0, it doesn't matter. It is the exact same. So again, homozygous dominant individual times a heterozygous, or a homozygous recessive. And then lastly, you have the winged times winged. So you know you'd have at least one homozygous dominant because you don't have any wingless. So you can't have any, this second letter, the second allele cannot be a little a because you cannot have any options to get a little a. You can't have any possibility of getting a wingless because there are no offspring with that phenotype. However, this other individual, so the other allele would be a big A because it's a winged individual. But you don't know what this other letter would be because it could be either a capital A or a lowercase a, and you would get the same outcome. So really quickly, I'll show what I mean. So big A times big A. Again, you would just get big A's across, big A across the board. This would show up as winged. However, if you cross it times a heterozygous individual, you would also get the same outcome because this big A is dominant. So you don't really know. That's why you have to put the dash because it can be either or. So I'm going to move on. And here's some of the different like crosses and how you can figure out what they all are. So again, has to be homozygous dominant times homozygous dominant because again it's selfed, so it's the same genotype, and you have 0 wingless. And the second one, you have a 3-to-1 ratio. So start kind of picking up and honestly memorizing the quick genotypes and phenotype ratios. It'll help save you time in writing out the Punnett squares. But again, a heterozygous times a heterozygous is going to give you that 1 to 2-to-1 genotype, but that 3-to-1 phenotype. And then you had a wingless self. So again, has to be a homozygous recessive times a homozygous recessive because you can't have any possibility of getting winged individuals, and they're also dominant. So any type of capital A would give you winged, which is not possible. And then the fourth example, we only have winged, so it has to be a homozygous dominant times a heterozygous recessive, because again, you don't have any wingless individuals, so both big A's would have to overpower or mask the homozygous recessive little a. And then number 5, again, we have that pretty even split, that 50-50. So here you have half of them are heterozygous, which again would appear as winged, but the other half would appear as wingless or homozygous recessive. And then number 6, it is the exact same again as number 4. Doesn't matter the number as long as it is the 1-to-0 ratio. And then again, the last one, number 7, wing times wing. You have to have at least one homozygous dominant individual because you can't have any possibility for recessive, but because it's a wing times wing, you can't have any possibility of that wingless because there are none. But you don't know what this other allele is because again it could be that capital A or it could be that lowercase a. Remember that the homozygous dominant and the heterozygous individuals they appear the same phenotypically. So I hope this video helped. Sorry for all like the mess ups and the recessive and the dominant when I'm saying homozygous. It definitely gets confusing when you're kind of saying out loud, but as long as you can remember like how to figure out what is dominant and what is recessive, you can always go back to Punnett squares. Again, I recommend kind of learning and memorizing those quick, like 1 to 2-to-1 ratio, 3-to-1 ratio, those kind of things. So definitely be able to identify what happens when you cross like a heterozygous times a heterozygous, a homozygous dominant times a homozygous dominant, homozygous recessive times homozygous recessive, and then a homozygous dominant times a homozygous recessive. So just kind of start picking up on some of those pretty common parental genotypes to help you save time in writing out the Punnett square.